Today is November 18th, and the back lot is being finished for asphalt. You can look at the weather that we're having today, considering it's November 18th in western Pennsylvania, in the Appalachian Mountains. Mother Nature sure is looking out for us. The concern we had is that the hot batch plant would close before we were able to get this done and have to be delayed till spring. Here we can see the skin on the front of the building being finalized. Again, a big emphasis, if you notice, on the insulation. We have a vapor barrier there. Very critical for moisture transmission concerns. Are you the fellows that put up the Dry-vit?
Yes, sir.
Cool, cool, cool. Shooting videos, show people what it's all about. What is the process? You put the polystyrene foam board on first, and then the stucco goes over the top of that?
Yeah, get the fiberglass mesh, stucco over top of it, and then the finish goes.
Okay. Do you guys have any restrictions as far as temperature to work under, other than it raining or something of that nature?
It's got to be about 40.
About 40 degrees? Does the stucco chemically cure just like the concrete does? Basically the same process? And you hand trowel that all on, right over the mesh that'll go on top of the foam board there.
Yes, sir.
Okay. Does this come the whole way down this wall? This whole wall gets done?
All the concrete block on the outside.
Okay. This is material they use basically as a glue to put the foam on for the Dry-vit. It's for all those people that want to build a rink and they don't know all the process, but they're not construction people.
Then that's done. They're done laying their block in there then, right? Why no DM? Alright. I can put the mesh around that. Hey, Leroy. There you go.
Hey, is there any particular reason they strike the block? They actually didn't have to strike it on the outside, did they? They're just so used to doing it the way they do it, they always just...
No, but I know from laying block myself that striking a joint it makes the block firmer.
Really? Makes it a better joint?
Yeah, makes a better joint.
Okay. Is there anything that's special as far as preparation for you guys for doing the Dry-vit that's required, or just goes right on the standard block, nothing special?
Oh, that's right.
What are you spraying down? A curing compound? All the concrete that's used outside can use a specific curing compound. We're indoors where there's going to be rubber flooring glued down. We don't want to use this type of material. It'll prevent the glue from being, the glue mastic from sticking properly. Often that's a mistake made in arenas. Now here we see the work of a pro, a painter exercising his art. A man whose pride can't be matched. A man who's going to tolerate the epoxy in the internal core area some way, somehow. Leonard, what should owners watch out for when they order steel and primer? Other than it should have been a gray primer, which would have covered easier.
This?
Yeah. Anything special as far as preparation or paint that you could give advice for future people?
Make sure the steel's not damp before you prime it.
Really? Is that what the problem was with the steel here?
It's rusted underneath, yeah.
Really?
Yeah, it had to be damp when they primed it.
Really?
Yeah.
Do you feel that the gray primer would have helped with covering?
100%. 100%.
Really? I usually tell my customers to do that, but somehow I forgot to do it.
Hey, you know, for everything. Yeah. Hey, how'd you ever make out with that?
Okay, one going back to the office.
Okay.
Martha should
Standing here, looking at the exterior doors, you can see the amount of gaps in the doors. And it's important to have proper weather stripping so they seal. Otherwise, especially during the summertime and during high humidity conditions, it would be oppressive to the rink environment. There's another set of doors in the back of the arena. You can see the amount of gaps in between them. You take a typical arena with here's the hollow core for the front section of the building being completed. This will be the end of the rest of the hollow core. You can also see here where the kiosk has been left in the masonry. That'll be to tie the canopy in and over the front vestibule area. Here the rink floor fine grading process is continuing. The header trench is the very first thing to get formed out after the fine grading process starts. This will be fully boxed out and act as a template for the fine grading elevation. This vapor barrel will be opened up to the rest of the rink floor, as you'll see in later videos. Here is used with the laser grading operation to make sure that the elevation of this trench is actually perfectly level. It's very important to the overall rink floor. You're an early skater. Starts on the rink floor. You're a movie star now, Jonathan. Said you're a movie star now. Mechanical room piping commencing. Let's look as its process is being undertaken. Here the fine grading process is continuing. You can see how the fellows have manually put piles of sand on top of all the individual tubes to hold them in place to their on-center positions. So as the tractors bring the larger quantity of sand over, the tubes won't move. We're in the vestibule area, which is being constructed in its masonry. This will be a side window, which you'll see. Same on the other side. As we come in, continue the construction. This is where the elevator is going. An out room, ticket window, pro shop, center core area, offices, another ticket window, and meeting and general purpose room. At this point in the project, they're prepping the floor for the radiant floor heating system, as you can see here in the skate rental area and pro shop area. The radiant floor heating system is a very efficient way of heating a building of this nature, and it doesn't create a lot of turbulent airflow, which we wanted for the special effect lighting and smoke that we're going to be putting even in the hallway area. Essentially what they do is they put a layer of 2-inch polystyrene board down, and they put some wire mesh down right on top of that, and the wire mesh is used to act as a tying agent for the tubing. They'll lay the tubing on top of that and tie it off to the wire mesh to hold it on center to center dimensions. Here we see the red iron used for manufacturing the fire escape stairs to the second floor. They come basically in sections and they build them on site. inside the stairwell where they're erecting these. They're starting to put the steel up for them. Go away to the second floor. Here we're up on the second floor where they've poured the skim coat on top of the hollow core. As you can see, the surface is totally smooth and been power troweled over the whole floor. It's ideal, ready for padding and carpeting. And of course the interior walls for the second floor office area. Roof is essentially all on, except for the ridge area. This still has to be closed up. Very last thing to be done. Workers are continuing skinning the outside of the building. What's today's date? 28th? Today's November 28th. Probably 65 degrees outside, sunny. Couldn't ask for a better day. Steel erection crews continue to put up the skin on the manufacturing side. The outbuildings where an EDM style roof is going to be placed. The roofs are done, but the EDM is not in place yet. Here you can see the roof drain. Going to capture all the water off the top of the flat roof. Now we're on the rink side of the building, looking at the top of the outbuildings where the rubber roofing has already been put into place. For 5 ETPM. See the roof drain. The other outbuilding. The upstairs center core area again, looking at the ductwork put into position. And you can see what they do is they start out with a very large ductwork and they start throttling it down to a very smaller ductwork the further it gets away from the point of entry. There's a fiberglass duct that both insulates and controls the course of the air. Here we see the opening that's been formed out for the ventilation chase, which will hook up to the exhaust hoods on the concession stand grills. Here we see the opening just shown from the bottom side and how the hollow core was supported by a structural steel lintel that spanned over the two adjoining hollow core sections. Those fine grading operations continuing over the subsoil heating system. An area the subsoil heating system has been covered. back in the mechanical room. You see the copper pipings going up. Shows the heat exchangers for the subsoil heating system. Here's the SST heat exchangers. So we see the rink piping system delivered. Now they're all prefabricated. This is the perma-pipe rink piping system. You see the piping system comes even fit for the radius. This is the radius mat here with all the U-bends in place. Building progressing. They've got an awful lot of the block just about done in the center core area, all the way up. Go see what's going on inside. Side's moving along very, very quickly. You can see the insulation's down on the floor. Starting to look like a rink. Upstairs, they've started. Here we're on the second floor, seeing the stud wall going up. This will be covered with 2 layers of 5/8 drywall on both sides to get the 2-hour fire rating required by code. An important factor to contemplate in the design is how this top wall will terminate to the pre-engineered metal building. Essentially what we're doing with this wall is the insulation will be cut back and the drywall will be pushed up tight to the metal decking on the roof and stopped with a bars fire stop type sealant. Looking down over the rink floor. See the center trench, how it's left. This location, where there's a section of insulation missing, was an area that the grade showed an irregularity that they were able to feel underneath the insulation. So as opposed to aborting it and letting the grade be off, they pulled the insulation back up and just touched up that grade. That could have been from somebody draining. Here we see the radiant floor heating system being put in. The rental skate area and the pro shop area. Here the rink floor is progressing. Rink piping system is being put in.
What's the word?
Oh, what I wanted was the power from you so I can see Now he's gonna fax it to me. I had the guy from Dell once and he gave us the price. And he had two guys quit on him last Thursday, so he called, sent this guy over. He said that he can't do it. He can't do it.
Let it match go out. We're on the perma-pipe system for a permanent year-round sand-based floor that we use. See how labyrinth the tubing arrangement is. There's approximately 26 miles of pipe in the perma-pipe system for a full-size rink. Here we're walking over towards the header trench location so you can see how that looks. We're at the header trench location where the headers are being assembled. You see here where the edge of the rink is, we have a perimeter tube that goes in first. It's tied with the anchors to the perimeter. What this does is ensure that we have real good refrigeration effect around the outside perimeter and good ice quality right up to the edge of the dashboard. Every U-bend is tied into position, and those wire ties will be cut back and trimmed. But there will be absolutely no possibility that we have a gap between the ice and the dashboards or any soft ice conditions on the perimeter with this approach. Here the center floor getting forced. Connection for a consultation counter, shoved up. Here in the rink area, see the board going up. This hip wall will be for the solarium that'll cover this area. You see here how we left the gap between the boards and the hip wall. The reason for that is so the boards will move. Somebody checked into them hard. Radiant heaters are installed. Upstairs area, whole wall is up. The offices are being framed out upstairs right now. Here we are in the entranceway. We have glass sliding doors. There'll be our elevator ticket window. There all the sand's been put in the rink floor. The very first process is to totally saturate the sand so it's free of air. And the reason we want it to be free of air is so that it'll conduct heat properly, and it'll also give us the structural integrity that we need for the heavy ice resurfacing machine to run over the ice sheet. This process takes probably about 2 to 3 hours to fully saturate the sand. They'll do that with a 1.5-inch fire hose. Have to be very careful when they're putting the water down too, not to direct the spray directly onto the sand where they'll gouge the sand and make it unlevel. As you can see by how the water is essentially level over the whole area. The sand floor has been put down to a very close tolerance. Essentially it's within about 1/4 of an inch over the whole floor. The ice sheet itself, they start 1/2 inch below the concrete perimeter. So as we build the 1 to 1.5 inch ice sheet over the rink floor, it'll actually be built right up onto the kick plate. The perimeter tubes underneath that kick plate will have good ice burrs right against the dashboard. Here we see the batterboard dashboard system. And nice benefit to the batterboards. There's no penetrations on the facing anywhere. No screws whatsoever.
I don't know. I need to pass out.
In the general construction yet, the doors to the main entranceway here from the solarium haven't been installed. The hip wall is fully installed. The solarium is being installed in the next few days.